In this video, we're going to talk a little bit about quadratic functions. And quadratic functions are a lot like quadratic equations. So remember, a quadratic equation has the form ax squared plus bx plus c equals 0. A quadratic function is just f of x is equal to ax squared plus bx plus c, right? It's a function that's that usual quadratic form that we see. Now suppose I want to graph this function, right? I'm kind of interested in graphing a function ax squared plus bx plus c, a quadratic function. I can sit here and I can plug in values for x, and I can find the points, and I can, plot them on the graph all I want, till I'm satisfied. But there's a much easier way to do it, and it takes advantage of the transformation of functions formula. If you've seen that, I did a video on it. I think it was my last video that I uploaded about college algebra as I'm recording this. So I would point you to that if you don't know, but I'll go over it again. But the way we get that is by completing the square of a general quadratic, or we're going to show how to complete the square of a general quadratic, but in general, we're going to complete the square of a quadratic function. And so first I'm going to give kind of the general case. So we're going to complete the square for ax squared plus bx plus c. And then we'll do more specific examples after that, but I just kind of want to give the general idea of what's going on. So it's okay if you don't follow me. You may even want to skip ahead if you want to see some more concrete numbers. Okay. So the first step I'm going to do here is I'm going to factor out a from these first two terms. So if f of x is equal to a times x squared plus b over ax plus c. So I just factored out a from the first two terms. Okay. Next, what I'm going to do is I'm going to add on the inside here, add and subtract b over 2a squared. So this will make me have f of x equals ax squared plus b over ax plus b over 2a squared minus b over 2a squared plus c. Notice that this plus and this minus will cancel and give me a 0, but we're not going to cancel them. What we're going to do is notice that this ax squared plus this ax squared plus b over ax plus b squared over 2a squared, it's going to give me a perfect square. Namely, let's see here, I have f of x is equal to a times, we're going to have x plus b over 2a squared minus b over 2a squared, and then plus c. Okay. So I just contracted this, these three terms here into the perfect square that they are. And if you want to verify that these two are equal, you can go ahead and do that. I'm not going to do that here. I have a video on completing the square. And then now what I can do is I can take this negative b over 2a squared and pop it outside. And I will have f of x equals a times x plus b over 2a all squared plus c minus, so when I pull this out, what I'm kind of doing is distributing this a to each of these. When I say I pull out, I'm distributing this a so that I can break it apart. So plus c minus a times b over 2a squared. This is f of x is equal to a x plus b over 2a squared plus c minus b squared over 2a, right? So to get from here to here, what I did is I have b squared over 2a squared, this should be a 4 actually, times a, right? So I have a times b squared over 2a squared. That's equal to b squared over, well, we'll say ab squared over 4a squared. This a will cancel with one of these a's and give me b squared over 4a. Okay? But in general, my vertex form, we call this vertex form, so I'll write it here. Vertex form is f of x equals a times x minus h squared plus k. What I want you to notice is that this minus h here is a constant. H and k are constants, right? This h here corresponds to b over 2a, And this c minus b squared over 4a is k. They're constant. They're all constant. They were in terms of the original constants that I had, the coefficients of my equation. But TLDR, the vertex form is f of x equals a times x minus h squared plus k. Okay? And we call the reason we call this vertex form is because we can read the vertex of the parabola straight off of it. So when we're looking at, for example, like let's say this is my parabola that I'm looking at, something like this. This point is the vertex, and we can read the vertex right off of this. The vertex, this point here on the parabola, this one, is going to be hk. That's the vertex. We can tell that based on the transformation that's happening to x squared here, right? So if I consider my parent function to be f of x equals x squared, think about this. Well, this vertex form is just, okay, vertically stretched by a units, flip if a happens to be negative, then move to the right h units, then move up k units. Well, if my original vertex on a parabola, right? Think about my original vertex on a parabola. For the parent function, the vertex is 0, 0. So then if I move the curve right h units and then up k units, the vertex will be at exactly hk. So this is why we can read the vertex off of the vertex form. We say that the point hk is the maximum of the function if for any x, so I'll write for all x, f of x is greater than or equal to f of h, which is k, right? So if no matter what I plug in to f of x for any x, if it is greater than or equal to k, that hk is the minimum. Hk is the maximum if for all x, f of x is less than or equal to f of h, which in this case is again k. So if f of x is less than k, less than or equal to k, for no matter what I plug in for x, then the point hk is a maximum, okay? So let's look at this like with some actual numbers, and let me stop speaking nonsense with variables here. So we want to find the vertex form of the following quadratic functions and determine if the vertex is a minimum or a maximum. Okay, so let's look at number 1 here. So f of x equals 2x squared plus 3x plus 4. And we want to write this first in vertex form. So how are we going to do that? Well, let's start. Our first step is to factor a off of the two terms. So in this case, a is 2. So I'm going to factor 2. So I have 2 times x squared plus 3 halves x, and then plus 4. Good. Okay, now I can add and subtract. So remember, this is a, this is b, this is c, and what I want to add and subtract is b over 2a squared. So for this, that is b, so b is 3 over 2 times a. A is 2, so 2 times 2 is 4 squared. So what I want to do here is have 2 times x squared plus 3 halves. It's important that we do this inside the parentheses, right? So I'm adding and subtracting inside the parentheses. So 3 over 4 squared minus 3 over 4 squared, and then outside of the parentheses plus 4. We always add and subtract the thing that we're using to complete the square, this b over 2a squared, inside the parentheses here, okay? That allows us to keep the equality and we're not having to multiply by anything. Now I can go ahead and notice that this here is going to be the perfect square, x plus 3 over 4 squared, okay? And then I have minus 3 over 4 squared. Okay, so all I did was just rewrite that perfect square there. Everything else stayed the same. And you might be asking, well, how did I know that that is the perfect square for that? So in general, we have that if you have x squared plus b over a, x plus b over 2a squared, that is the same as x plus b over 2a squared, okay? And if you want some more information about that, I have a completing the square video in the College Algebra playlist, so go see that. So continuing here, I'm going to go ahead now and distribute this 2 to each of these. So I'll have f of x is equal to 2 times x plus 3 over 4 squared, and then it's going to be minus 2 times 3 over 4 squared plus 4. Okay, and I want to point something out really quickly. So notice that I wasn't quick to take care of that 3 over 4 squared, right? I'm not excited to. I don't want to work with fractions if I don't have to, yeah? So I just leave it as it is until I have to do this step, right? So my next step is where I actually have to deal with it. But up until this point, I didn't even consider it, right? I just left it as it was. And that's perfectly fine, you know? Until I need to work with it, I really don't need to, okay? So now let's go ahead and look at that 3 over 4 squared. Well, 3 over 4 squared is the same as 3 squared over 4 squared, which is 9 over 16. And then I have, so let me go ahead and rewrite my equation here. It's going to be f of x equals 2 times x plus 3 over 4 squared minus 2 times 9 over 16 plus 4. Okay. Now I can go ahead and distribute this 2, and it'll cancel with this 16 and leave me with 8. Okay, so I'll have f of x equals 2x plus 3 over 4 squared minus 9 over 8 plus 4. Now what I want to do is give these a common denominator so I can add them, these two terms here. Okay, so I'll multiply this by 8 over 8. This is going to give me, so just doing this here, this is negative 9 over 8. This is going to be plus 32 over 8. So 32 minus 9, that's 23. So this is going to give me 23 over 8. So my final form here, this is the vertex form, 2 times x plus 3 over 4 squared plus 23 over 8, okay? And that mirrors that form that we wanted, right? Our vertex form is f of x equals a times x minus h squared plus k. Now you might be saying, well, what about that negative h? Well, that's just a convention that we use. So I can actually rewrite this if I want this to be in terms of x minus h. I can rewrite this. So maybe we'll call this my final form. F of x is equal to 2 times x minus negative 3/4 squared plus 23 over 8. And it should be clear now how this is minus h. So now I can identify that this is h and this is k. So my vertex, remember, is hk is equal to, in this case, negative 3 over 4 and then 23 over 8. Beautiful. Now, the second part of this, maybe I'll move this over here to give myself a little bit more room. Now, the second part of this question is let's determine if this value is a minimum or a maximum. Okay, so all we have to do to determine if it's a minimum or a maximum is just plug in some value to our function and see if it's greater than k or less than k. Okay, so maybe we pick an easy one. Let's pick 1. Why not, right? So let's test f of 1. Well, f of 1 is 2 times 1 squared, so I'm using my original. I just as easily could have used the vertex form if I wanted to. But this is 2 times 1 squared plus 3 times 1 plus 4. Well, that's just going to be 2 plus 3 plus 4. That's going to be 9. Okay, So now my question is 9 greater than, less than, or equal to 23 over 8? Okay, so let's look at 23 over 8. Well, 23 over 8, you would probably agree with me, is less than 24 over 8. And 24 over 8 is 3. Okay? So this tells me that because 9 is greater than 3, and 3 is greater than 23 over 8, 9 is greater than 23 over 8. So it must have been the case that HK, which is negative 3/4 23 over 8, is a minimum. Because any arbitrary point is greater than or equal to this vertex, right? We only need to pick one, because our vertex, right? So let's look at two separate cases. If our vertex is a maximum, then every point is less than that. It doesn't matter what I pick, it's going to be less than that, right? So I can pick any point, and as long as it's less than, I have a maximum. Alternatively, if it's a minimum, I can pick any point, any x value to plug in, and it'll be greater than that minimum. So I picked 1 arbitrarily, but I just as easily could have picked pi or 5 or 12 or anything else, and I would have gotten that this is greater than 23 over 8, so it must have been a minimum. Okay, let's move on to the next example. G of x is equal to negative x squared plus x plus 9. Okay, so the first thing we want to do is get it into vertex form. Recall our vertex form we want is going to be, it's going to look like g of x equals a times x minus h squared plus k. Okay, and we do that by completing the square. The first thing I do to complete the square is factor out the first number. So I factor out a -1. Factoring out a -1 just flips signs, so this is going to be x squared minus x, and then I leave the last term alone, just like before. Now I want to add in this, inside the parentheses, I want to add and subtract this factor of b over 2a squared. So remember, a is -1, b is 1, c is 9, right? So just our normal quadratic a, b, and c. So b over 2a squared, is going to be plus or minus. b was 1, and then 2a is going to be -2 times -1, so I have -1/2, okay? Which is the same as 1/2 squared, right? Okay, plus or minus. So I want to add and subtract that in those parentheses. So g of x is going to be equal to -1 times x squared minus x minus 1/2. Sorry, plus 1/2 minus 1/2 plus 9. Okay? This square here, remember, is, so I'll go ahead and omit this. My b over 2a, so I'm trying to determine what kind of perfect square this is. So it's always going to be of the form x plus b over 2a squared. b over 2a was -1/2, right? b over 2a, -1/2. a was -1. So this is going to be x minus 1/2 squared minus 1/2. All of that is being multiplied by -1 and adding 9. Okay, so all I did here is rewrite this square. Now I can go ahead and distribute this -1. So I have negative x minus 1/2 squared plus 1/2 plus 9. Okay. And then finally I can combine that that positive 1/2 and that 9 by giving this a common denominator by multiplying by 2 over 2. This is going to give me just this bit here, 1/2 plus 9 times 2 is 18 over 2. This is going to be 19 over 2. And then what I'm left with is that g of x is equal to negative x minus 1/2 squared plus 19 over 2. Okay. Now this is vertex form, and I can go ahead and read off h and k. So h is positive 1/2, and k is 19 over 2. So this tells me that immediately that my vertex hk is 1/2, 19/2. Okay, great. So that's my vertex. Next, I need to determine if it's a minimum or a maximum. So again, we're just going to pick any point. We'll say x, maybe x is equal to 1, just for sake of computation, ease of computation. So we're going to take g of 1 to compare it to k, which is 19/2. So g of 1 is equal to -1 squared plus 1 plus 9. That's the same as -1 plus 1 plus 9. This is not -1 quantity squared. This is -1 squared. -1 squared. 1 squared is 1, so this is -1. So -1 plus 1 is 0, so all I'm left with is 9. Now let's think a little bit about 19/2. What quantity is this? Well, this is the same as 18 over 2 plus 1/2, right? Good enough. So this is the same as 9 plus 1/2. 9 plus 1/2 is greater than 9. So my vertex is greater than g of 1. So I'm looking at a situation where my vertex is greater than g of 1. So my parabola must look like this, and I must have a maximum. Okay, great. Okay. So next, let's look at another example. Two numbers have a sum of 15. What is their maximum product? Okay. Well, let's think about how I can write these numbers out, right? Because I need to give them some unknown quantity, some variable, so that I can solve for them. So let's think about it. Well, I know that x plus y, let those be my two numbers, are going to equal 15. The sum of them is 15. This also tells me that y equals 15 minus x. I just subtracted x from both sides. So importantly, I can rewrite my two numbers as I can rewrite y as 15 minus x, and x is just x. Okay, so my two numbers are x and y, where x is just x, unknown, and y is 15 minus x. And I want to find their maximum product. Well, we can think of their product, right? So x times y is going to be x, just x, times 15 minus x. Okay? And we can define this as a function, say p of x, because it's only in terms of x, p for product, we'll say. So p represents the product of x and y in terms of x. Now we can go ahead and do this multiplication here, just distributing this x to get 15x minus x squared. Okay? We can find the minimum product by noting that if we get this into vertex form, we have a way to determine if a vertex is a minimum or a maximum. So we can determine what their maximum or minimum product is, right? So let's take a look at this. Just for the sake of keeping things consistent, I'll rewrite this as -x squared plus 15x, okay? Now I can complete the square by factoring out the first number. Okay, well, I guess first I should note that this is a and this is b. I'm going to factor out a. That just flips the sign of everything, so I have x squared minus 15x. I just multiplied everything by -1 and factored out the -1. Okay, and now I'm going to, in the parentheses, add and subtract the b over 2a squared. Okay, a is -1 and b is 15, so this is going to give me 15 over -2. So importantly, b over 2a is -15 over 2. Okay, now I'm going to go ahead and add and subtract that inside the parentheses. So this gives me p of x is equal to -x squared minus 15x plus 15, we'll say -15 over 2 squared minus -15 over 2 squared, all inside the parentheses. Okay. This is a perfect square. That perfect square is x minus 15 over 2 squared. That's all I changed. I just rewrote the square. And then it's going to be minus negative 15 over 2 squared. Okay. I can go ahead and distribute this negative now and have p of x is equal to negative x minus 15 over 2 squared plus, sorry, minus, plus 15 squared. 15 squared is 225. So 15 squared, 225. 225 over 4. Okay. So this tells me that I can read off immediately that h is 15 halves and k is my vertex hk equals 15 over 2 and 225 over 4. Okay. Now I get to figure out if this is the minimum or the maximum. It should be pretty clear that it's a maximum, but we'll just double check. We'll plug in maybe, let's say, p of 1. P of 1. So I can use this, we'll use this top one here. So p of x is x times 15 minus x, so 1 times 15 minus 1. That's just going to be 14. Okay. And then 225 over 4. So 225 over 4 is the same, or it's going to be greater than 224 over 4. 224 over 4 is the same as 112 over 2, which is the same as 56. 56 is much greater than 14, so we must have had a maximum, and that maximum product is p of x at 15 halves. Right? P of x represents my product in terms of x, and the maximum product was 225 over 4. So this was my max product. Okay. That wraps up what I have to say about quadratic functions. If you found this video helpful, please consider liking and subscribing. Thanks.